In previous videos in this series, the load support element, technology that was available to the pyramid builders, is modified by using the properties of negative displacement in sand. This extends its function to supporting loads at higher positions capable of being lifted manually or separately with levers. However, the lever on its own still has limited stroke capability. The final solution to lifting heavy loads over significant distances is found by combining these two technologies, both known to Archimedes, in one machine I call the Archimedes Jack. In this video, an extract from another animation demonstrates how two containers with support props may be connected together with a lever at two pivot points at the top of each prop. Like this, when the containers are filled with sand, operation of the lever up and down causes each prop in turn to be incrementally raised. The prop on the end of the lever is typically used to support the primary load, designated the load support prop, while the other prop is used to support the lever's normal pivot point while raising the load, designated the lever pivot support prop. During an upward stroke of the lever pivot point automatically changes to the load support prop. The combination of a lever and load support elements extends the capability of each separate component to provide a simple machine with far superior characteristics, the Archimedes Jack, which could have been used to raise loads up the steep side faces of the pyramids without a conventional ramp, that is, a steep stepped ramp with a jack on each level. This animation shows a stepped ramp in operation. A complete jacking machine has a minimum of 4 Archimedes jacks, a pair working together on each side. In this diagram, each prop under the load represents a complete Archimedes jack with 2 containers, a lever and a worker. The levers would be projecting in and out of the diagram. Workers stay on the same level throughout the working day. The machines on each level work in synchronous harmony, with a 25-minute cycle and 15 minutes phase lag between them, so every 6th level works in phase. More machines are added as the pyramid height increases level by level. A simple demonstration shows again the basic principle of the jack, being able to support the load and the lever pivot as the load is raised, with 2 load support elements. By operating a lever connected to the top of each prop, each one in turn is raised, incrementally supporting the load and the lever pivot at higher positions. The load may be indefinitely supported or lowered by allowing sand to vent from the bottom of the containers. Now the jack can be reset by refilling the containers with sand. This can be repeated over and over again.